Example 3 from section 3.3 asks us to determine the vertex of a quadratic function by completing the square. So we do that by writing it in vertex form. And then we're going to use the process of completing the square to verify the relationship between the value of p in vertex form and the values of a and b in standard form. And if you remember that from, I guess from section 3.2, we learned that p was equal to negative b over a. Okay, b over 2a, sorry. So we just have to verify that. Okay, so here we'll just begin by completing the square for this function. Okay, we know how to do that fairly well now, I hope. And so we begin that by taking that 5 out of those first two terms. Okay, we end up with x squared plus 6x, right? 5 times 6x equals 30x. Check it. Make sure that I'm going to write my 41 here. Okay, let's decide what we need to have in brackets there. Take the 6 and divide it by 2, you get 3. Okay, and then you square the 3 and you get 9. Okay, what have I done? Well, I've actually added 45 here because I added a 9 that's multiplied by a 5. So I'm going to subtract the 45 to undo that so I don't actually change my function. Don't want to do anything that actually changes my function. And I end up with 5 times x plus 3 squared minus 4. Okay, so what do I have? I've got a function. I've got a parabola that's going to be quite narrow. It's going to open up, and it's got its vertex at negative 3, negative 4. Okay. Let's see. So it asks us then what the maximum or minimum value of the function. Okay, so we know that if it's going to open up, it's going to have a minimum value. So it's going to have a minimum y value of negative 4 when x is equal to negative 3, right? Okay. And then in B, it asks to verify this, or sorry, to verify that p equals negative b over 2a, okay, by going through these steps again. Okay, so I want to take this. I think I'm going to take this whole thing, and I'm going to copy it for you. Okay. Let's see. Actually, no, I think what I'll do is I'm just going to show 2 pages side by side. Now let's do that. And get a new page. Okay, and so we're going to look at the steps on the one page, and okay, and we'll just kind of go along, and we'll do it in sort of a general form. So instead of having, okay, all right, so taking this, instead of having that, I'm just going to do a basic standard form. Y equals ax squared plus bx plus c. Okay. Now, in the second line, what I did was I took out that coefficient of 5. And in this case, that'd be like taking out an a. Okay? That leaves me with x squared plus. And so if I've taken a factor of a out of b, I've basically divided b by a. Okay? And here's a good opportunity to verify by multiplying back a times b over a. The a would just cancel and give you b. Okay, so you know that that's the right thing that you have there in front of the x. Okay. All right. What I do then is I leave that space. Okay. And I leave another space, and then I have my c on the end. Okay, and I'm sorry that it's gotten a little squishy here. I'll just move it over. Okay, I want it to be lined up. Okay, so yeah, I did that step. Okay, I haven't added anything yet. So what do I actually end up adding? Well, what I end up adding is I take half of this, right? I always want to take this coefficient of x, and I want to take half of it. So basically, b over a. So I divide by 2 or multiply by half. And you know, it's rational number multiplication. So do the numerators by numerators, denominators by denominators. Okay? And so that's what I take, the b over 2a. Okay? And so to get that other term, I always square that, right? And then you end up with b squared over 4a squared. Okay? That here is b squared over 4a squared. Okay? Need a little more room there, hey? So I'll put my c here. Okay, what have I actually added? Well, I didn't add b squared over 4a squared because I added that multiplied by a. When I multiply that by a, all it does is cancel out one of those factors of a in the denominator. Okay, so to undo that, I'm going to go minus b squared over 4a. Okay. Okay. And then okay, so that's this whole step right here. Now this one here is when I write it as a binomial. Okay, and that's where I keep my a on the outside, and it's x plus, okay, and then whatever we took as the half of b over 2a, or b over a. So half of b over a is b over 2a, square that, okay, and I'm just going to group this a little bit because it's plus c minus b squared over 4a, okay? Why did I do that? Well, now I have it in vertex form, right? I have my a value. Okay. So if you compare this to vertex form, you get y equals a times x minus p squared plus q. Okay. So the relationship here then is that if you look at these two, you know that p, they're negatives of each other. So let's put the p as positive. We'll say negative b over 2a. Okay. So we verified that p, the coordinate of the vertex, can be represented by negative b over 2a. And just if you remember when we were in 3.2, in our summary of 3.2, we also said that q is equal to, and I'll just look at this in the book, where I find where it is. Oh, yeah. That's on page 166. We found that q is equal to c minus a p squared. Okay, and then if you put that c minus a times, put that negative b over 2a, okay, squared, and you get c minus a b squared over 4a squared. Oops, that was squared. Okay, and then you just end up canceling out that factor of a, so c minus b squared over 4a. Okay? Why did I do that? I don't know why I did that. Oh, yeah, because that's what I have up here. I just wanted to show you that this equals this. Okay? So just to verify that both of these things are valid, okay, verifying them by completing the square. Okay? I didn't have to do that thing with q, it just asked you to do it for p, and so we did that. So use your relationship from part B to determine the vertex of the function. Okay, so in part B, if we actually use these two relationships, okay, we can find that based on our original standard form equation, p equals negative b over 2a, or negative 30 over 2 times 5, okay, which is negative 3, okay, and q equals c minus a, well, let's use what we actually have up here, okay, we actually had in our rearranged equation, c minus b squared over 4a, okay, so 41 minus 30 squared over 4 times 5. So 41 minus 900 over 20, okay, which equals 41 minus 45, which equals negative 4. Okay, so our vertex is negative 3, negative 4, which we found by converting into vertex form. Okay, so we've that's C basically. Okay,